Hello, and this time looking at 3D trigonometry, which isn't really 3D trigonometry. It's normal trigonometry on a 2D triangle. It's just that triangle might exist in a three-dimensional context. So in this case, we've got a triangle going across the diagonal of a cuboid. So that's the 3D element. We're still going to do normal trigonometry. We just have to think about what's a right angle and where, and how do we get the sides we want. So just a quick reminder for trigonometry, if we've got an angle in our triangle, right angle triangle, okay, the hypotenuse is the one opposite the right angle, and it depends where your angle is. The opposite side is not touching the angle and the adjacent side is touching it. Okay, but if I defined with the angle up here, this would be the opposite and this would be the adjacent, so be careful. Okay, we might also have to do some Pythagoras, and you can do Pythagoras in 3D in one fell swoop. So let's say we've got this here. It says work out the length of AG. So that is definitely moving in 3 dimensions. If you see, we've got to go across, up, and then inside the plane. So all 3 dimensions. You can do this in 2 parts. So if you think about it, okay, well, the side that I want is this AG, and this makes a triangle. They've even drawn it for us. With this side, which is just the height, so that's 7, so we know that, and this diagonal across here, you can imagine that this is the square at the bottom of the cuboid. Okay, I'm just getting messy here, so let's take all that out. And so this is the diagonal across that square. So let's draw that up here. It's that diagonal here between E and G. And we know that this is... Yeah, so I'm looking at this triangle here, yeah? So this is 10 and this is 15, and we can find this by doing 10 squared plus 15 squared square rooted. Pythagoras, a squared plus b squared equals c squared. And now we can look at this. If we know that this is the square root of 10 squared plus 15 squared, we can say, okay, well, this squared plus 7 squared equals this. And what is root 10 squared plus 15 squared squared? Well, the squared and the root are going to cancel, so we get 10 squared plus 15 squared. Yes, that's that side squared, because it's lost the square root, plus the 7 squared, and that's going to equal AG squared. Now, if you notice, that's just the 3 sides that were involved. That's supposed to be a 7. Very messy, sorry. It's just the 3 sides involved squared together, and you can absolutely do that. Pythagoras in 3 dimensions, you can just say the 3 sides that sort of 3 dimensions that sort of define the line, square them all, add them all, and that will equal the square of the one that you want. Okay, now if somehow you end up in 5-dimensional space, you can do it exactly the same way. It would be a squared plus b squared plus c squared plus d squared plus e squared equals f squared. Okay, it works in all dimensions. Obviously, we only really have to worry about 2 and 3 because unless you're a string theorist or some other, strange situation, you're not going to end up with that many dimensions to have to worry about. So working out a length, because in all 3, I'm just going to do what we had before, 15 squared plus 10 squared plus 7 squared, and square root it, pop that into my calculator, and the answer will be that length, AG, in centimetres. I'll let you do that though. Calculate the angle that AG makes with the plane EFGH. Well, EFGH is this plane here, and this plane here is defined by the line EG. The line EG is in that plane, okay? It lies on the face. If you imagine painting this face of the cuboid, then that line EG will have paint on it. So we can simplify this question to say, what angle does AG make with EFGH? Instead of EFGH plane, with EG as that angle. So it's just what's this angle here. Most of the difficulty with these questions is working out where you are actually wanting to work something out and what sides are involved. Then the actual maths is fine. So now here's our triangle. It's just a right angle triangle. We know this side is 7. You can either use the AG that you just worked out. That makes sense. We've just got it. So that whatever that is, I'm just going to call that H for hypotenuse. And if we want to know the angle, this is opposite and a hypotenuse. So it's inverse sine of 7 over whatever that hypotenuse was. Okay, so if you can't remember, it's Sokotoa or 6 old hags cooked a hot tub of arsenic. That's the way I remember it. And so opposite hypotenuse is sine, and to get the angle we do the inverse of the sine. So on the calculator that's shift sine 7 over whatever that answer was, okay, in order to find the angle. If you wanted to find a length, then you would obviously use normal sine on the angle. If all your answers correct 3 sig fig, again I'll let you work them out on your calculator to get those. Let's have another look, a look at another question. A vertical pole CP, so just there, stands at one corner of a rectangular horizontal field. It gives us AB, AD, and the angle, which are all labelled. This angle here, notice it's PDC, so it's going down to that line there. Yeah, it's in between those on the far side. Work out the height of the pole CP. Well, we know that that's 40, and we want a height. We can just ignore all this. It's just a triangle flat there. We've got the angle, we know the adjacent, we want the opposite, so it's going to be tan 25 equals the opposite over 40. So the opposite equals 40 times tan of 25. Pop that into the calculator. Make sure your calculator is in degrees when you do it, otherwise you'll get a funny answer. Just type that in and you'll get your answer. Boom, in meters. The angle of elevation, so that means the angle from the floor of P from B. So we're stood at B and we want the angle of elevation up to P, which is that angle there. So this is another just straightforward, not at all three-dimensional. We've got that's the next video I'm doing. We've got a right angle triangle there, and we want to know the angle this time, and we know this is 30, and you've just worked that side out, 18 point something I think it was. Yes, 18.65. It says 3 sig fig, but we should use more significant figures or use the ants button when we do another calculation. So in fact, I'm going to store that as A so that I can recall it in a moment. You mustn't round it and then use that rounded value in your calculation. That's just going to lose final accuracy for the follow-up questions. So if we know this and we know that, we can say that this is tan again, isn't it? But this is inverse tan, because we want the angle, of opposite over adjacent, so you're 18.65 blah blah over 30. And so we're going to go shift tan of our previous answer, so A, over 30, and that gives us an answer of 31.87 or 31.9 to round it as asked. And then the angle of elevation of P from A. So we want the angle between this side and this green plane, or if we, as we're going up to here, we can come down to the plane and then just finish off the triangle. Okay, so this time we know that height, great, but we need to know this length here, and we can just do Pythagoras on that because it's going across a rectangle. So the length of this side here is the square root of 30 squared plus 40 squared. And now again we just do exactly the same thing. It's going to be inverse tan of the opposite, which is our 18.65, or A in my calculator because I stored it so that I could use it again, and divided by the adjacent side, which is root 30 squared plus 40 squared. And you don't even need to work that out on these nice modern calculators. I'm just going to backspace and change the 30 to root 30 squared plus 40 squared and let it work the whole thing out by itself, and then it'll give you that answer that you can round to 3 significant figures as requested. Hopefully that gives you an idea through a couple of examples not to be worried about trigonometry or Pythagoras in 3 dimensions. The trick is to work out where's my flat triangle. Yes, you're not actually doing anything in 3D, you're simply taking a 3D picture and saying where is the flat triangle that I'm used to, that I can draw on this and pick out the side, and pick out the side, or pick out the angle, and then I can just do my normal trigonometry or indeed Pythagoras. Questions down in the comments if you have any, otherwise, cheerio.